Question 1. Another plate holds 7 cupcakes, each with a different color icing, and 4 brownies, each of a different size. So, given are 7 cupcakes and 4 brownies. Find the number of different ways these 11 cakes can be arranged in a row if no brownie is next to another brownie. These 11 are arranged in a line in a row. What condition it should satisfy is beside a brownie there should not be again brownie. Clear? And how we do that means we keep the brownies aside and arrange the remaining. Remaining is 7 cupcakes. So 7 blanks. 7 cupcakes in 7 blanks can be arranged in 7p7 ways. Since none of them are given identical, so by will not come. Now I should see in between how many places do I have for these brownies. Brownies should not be together means they should be placed in between. So I should see in between how many places do I have. So count 1, 2, 3, 4, 5, 6, 7, 8. 8 in between places for 4 brownies. So they can be arranged in 8p4 ways. If you put this in the calculator, you get the answer to be 8, 4, 6, 7, 2, 0, 0. Question 2. 8 children of different ages stand in a random order in a line. Find the number of different ways this can be done if none of the 3 youngest children stand next to each other. There are 8 children given. Condition is 3 youngest should not be together. From the 8 children, 3 youngest, other are 5. These 3 should not be together. Okay. And how do I make sure that these 3 are not together? Place them aside and arrange the left out children first. Left out children are 5. So 5 blanks. These 5 children can be placed, arranged in these 5 blanks in 5p5 ways. These 3 youngest should not be together means they should be placed in between the remaining. So now count in between how many places do you have. So 1, 2, 3, 4, 5, 6. So in between I have 6 places for these 3 youngest. So 6p3. Put this in the calculator, you get the answer to be 14400. Question 3. A library contains 4 identical copies of book A. Whenever you come across information, write it down. 4A, they are all identical. 2 identical copies of book B. So 2 of book B. 5 identical copies of book C. So 5 are of book C. These 11 books are arranged on a shelf in the library. Calculate the number of different arrangements if all the books A are next to each other and none of the books B are next to each other. This question is combination of together and not together. He told all the A's should be together and B's should not be together. Okay. Whatever should not be together, you put them aside, separate. Arrange the remaining. Remaining are 5 C's and 4 A. And also one more condition that should be satisfied is these 4 A's should be together at all times. How do I make sure that they are together? By considering them to be one unit. If I consider them to be one unit, only then I can be sure that they are always together. And 5 C's. So total is 1 plus 5, 6. These 6 can be shuffled in 6p6 ways. Okay. More. These 5 are for C, they are given identical. So whenever identical, so by 5 factorial. These 5 are identical, so by 5 factorial. And now inside these A can shuffle in 4p4 ways. And all the 4 A's are identical, so by 4 factorial. Okay. Now, these two B's should be placed in between such that they are not together. So, how many places do I have in between? Count. From here, 1, 2, 3, 4, 5, 6, 7. 7 in between places for 2B. So, they can be placed or arranged in 7p2 ways. Since those two B's are identical by 2 factorial. So put this in the calculator, you get the answer to be 126. Question 4. Find the number of different ways in which all 9 letters of the word can be arranged in each of the following cases. Whenever you come across a word, write each letter has come how many times. M has come twice. I is present once. N is present once. C is present once. E is present twice. A is once. T also once. Okay. Now, no vowel A, E, I is next to another vowel. I should make sure the condition that vowel is not next to another vowel. For that to happen, I put the vowel separate and arrange the remaining letters. So, A, E, I. Leaving this, I am arranging the rest. Rest are M, N, C and T. How many of them are present? 2, 3, 4, 5. So put 5 blanks. 5 letters, 5 blanks can be arranged in 5p5 ways and more. These two M are identical. So by 2 factorial. Okay. Now I should see in between how many places do I have for these vowels. I am checking for in between places, only that way I can be sure that vowels are not beside each other. Clear? Now count. 1, 2, 3, 4, 5, 6. So 6 places for 4 vowels. So 6 P4 and more. In the vowels, these two E's are identical. So divided by 2 factorial. Place this in the calculator. You get the answer to be 10800. Question 5. Find the number of ways the 9 letters of the word 17 can be arranged in each of the following cases. Whenever you come across a word, write each letter has come how many times. It is a good practice. So, S has come once. E is present 4 times. V is present once. N is present twice. T is present once. Okay. No E is next to another E. I should make sure that no E is present beside another E. For that to happen, I should leave this E separate and arrange the remaining letters. Remaining how many letters are present? 1, 2, 3, 4, 5. So put 5 blanks. 5 letters, 5 blanks can be arranged in 5p5 ways. More. In this 5p5, these two n are identical. So by 2 factorial. Okay. Now, this E should be placed in between. So I should check in between how many places do I have for E. If they are placed in between, only then I can be sure that no E is beside another E. So in between places are 1, 2, 3, 4, 5, 6. 6 places for 4 E's can be arranged in 6p4 ways. More. These 4 E's are identical. So by 4 factorial. Place this in the calculator, you get the answer to be 900 is the answer.